This isn't about just a few upgrades here and there. We're talking about a grid that is right on the brink. The numbers are they're staggering. Federal studies are really clear on this. To hit our 2050 energy goals, the US needs to expand its entire transmission system by up to 3.5 times its current size. Think about that. We don't just need a little more capacity, we need multiples of what we have. And check this out. The things demanding all this power are a whole new breed. You've got AI data centers, which alone are expected to add a crazy 65 gigawatts of demand by 2029, plus new semiconductor plants, EV factories. It's just a perfect storm of electricity demand all hitting at once. So the problem is massive. We get it. But here's the good news. The technology to solve this, it actually already exists. It's time to build an electrical superhighway. It's a technology called high voltage direct current, or HVDC. And the best way to think about it is like this. If our current grid is a bunch of local city streets, HVDC is the interstate highway system. It's designed to move huge amounts of power super efficiently over hundreds of miles, from where it's made to where we actually need it. And the advantages here, they're a total game changer. HVDC lines lose less than half the energy that our regular AC lines do over long distances. They also need a smaller physical footprint, which, let me tell you, is a huge deal for getting these projects approved. Plus, they can even make the whole grid more stable. Okay, so we have the demand, we have the technology, and we even have the money flowing from the federal government. So what's the catch? Well, the problem isn't money, it's physical. We've hit a massive billion-dollar bottleneck in our ability to actually build anything. I mean, just look at the basic hardware. If you need a large power transformer today, a piece of equipment that is absolutely critical, the wait time is somewhere between 2 and 4 years. Our supply chains are so jammed up we just can't get the parts we need. And hey, even if we had the parts magically appear, who's going to install them? We're facing a critical shortage of skilled workers. We've seen over 4,600 experienced line workers leave the job, just as demand for them is going through the roof. This chart just lays the whole crisis bare. We need to be building about 5,000 miles of these big transmission lines every single year. You know how many we built in 2024? Less than 900. We're moving at less than 20% of the speed we need to. And this quote from the source material just nails it. The US is capital rich, but build poor. The problem isn't a lack of money. The problem is our physical ability to actually get stuff done. So if your problem is a physical one, a human one, how do you solve it? Well, you bring in a force multiplier. You bring in a workforce that works 24/7, that can help the human experts we already have be way more productive. It's time to bring in the robots. And look, this isn't some sci-fi fantasy. Robots are already being used on the grid today. You've got autonomous crawlers inspecting high-voltage lines while they're still live, drones scanning for problems. This stuff cuts inspection times by more than half and, more importantly, keeps human workers safe. The tech is proven. Okay, so that's great for maintaining the old grid, but that leads to the real question, doesn't it? Can robots move beyond just inspections and actually help us build the new grid we so desperately need? And the answer is a huge, resounding yes. We are right on the edge of a revolution in how we build things. We're talking about autonomous trenchers, robotic systems that can lay heavy cables, and even automated systems that help put up those giant transmission towers. This is becoming real right now. I mean, just look at the difference. The old way is slow, limited by crews and weather, and it's dangerous. The new robotics-enabled way means you can work around the clock, you make your existing human workforce way more productive, and you take people out of the most high-risk situations. It completely changes the entire equation. But this is about more than just building faster. It's about creating this incredible economic engine, what you might call a virtuous cycle, where building the grid of the future actually helps create the industries of the future right here at home. So check this out. Here's how it works. Step 1, robots help us build the new grid way faster. Step 2, that awesome new grid attracts all those high-tech industries, the AI guys, the chip makers. Step 3, now those new industries create a huge, stable demand for American-made grid parts. And what did that lead to? Step 4, we build new automated factories in the US to make those parts, which, you guessed it, helps us build the grid even faster. It's a loop that just keeps feeding itself. And the return on investment here is just It's mind-blowing. A national investment of somewhere around $5 to $10 billion into this robotic workforce could unlock over $250 billion in benefits for the whole system. That is an absolutely incredible return. So we're at this really amazing moment in time. The need is undeniable. The technology is here, the money is available. For maybe the first time, we have the plan, the capital, and the tools to finally break through our physical limits. The only real question left is, how fast can we build?